Piraeus has always been a getaway city, a place of trade, culture, and energy. In recent years, we have worked intensively to open our city to Europe through tourism, entrepreneurship, and innovative projects. At the same time, we are fully aware of the challenges that come with our urban structure. Piraeus is the largest and busiest port in Greece, one of the top ports in Europe, and the key hub connecting Europe, Asia, and Africa. It is also one of the most densely populated cities in Europe and extremely limited green spaces. In fact, Piraeus has the lowest green space per capita in the European Union, just 1.56 square meters per residence, with open spaces covering only 2.12% of our city. On top of that, 11,000 acres of the city are covered by abandoned or former industrial buildings. These factors, combined with the increasing effects of climate change, make urban heat one of the most pressing issues. European funding, especially through Horizon programs, provide us with access to cutting-edge research, expertise, and partnerships that we could not achieve alone. Buildspace in particular allow us to combine satellite data, socio-economic insights, and advanced analytics to strengthen our resilience, protect our residents, and plan for a city that remains competitive and livable for decades to come. Through projects like this, Piraeus is aligning its actions with the European Green Deal 2030, taking a proactive approach to sustainability and climate adaptation while embracing innovation. For us, the urban heat analysis platform is like a new lens on our city. It enables us to clearly see where the pressure points are, urban hotspots where residents and visitors are most affected, and give us the opportunity to transform that insight into practical action, creating new green areas, building shaded corridors, upgrading public spaces, and improving building infrastructure. This tool is a clear example of how Piraeus uses European innovation not only to address today's challenges, but to reshape the city itself, improving quality of life, building a healthier and more resilient urban environment, and making Piraeus a more attractive destination for both residents and visitors. It is helping us create a city that can adapt to climate change while remaining vibrant and competitive for the future.
The Buildspace program began in February 2023, and the pilot phase required a long preparation that involved gathering local data, integrating meteorological, demographic, and energy use information, and working closely with our European partners, including the Polytechnic University of Madrid and Mobix. This early collaboration ensured that the tool would be adapted to the reality of Piraeus, a dense, complex urban environment with unique challenges. After several months of data preparation, model development, and internal testing, in June 2025, we hosted a live demonstration event at the municipality of Piraeus. This session brought together a wide group of stakeholders, municipal department heads, urban planners, public health professionals, researchers, and external experts. The demonstration featured real-time heat and vulnerability mapping, showing how satellite data, IoT sensors, energy demand layers, and socio-demographic information come together. It was very effective. Everyone could see the predictive modeling in action and how intuitive the interface is, even for non-technical users. That demonstration helped secure internal buy-in across departments and sparked interest for broader use. The standout feature is definitely the interactive heat risk dashboard with the energy demand overlay, which allows us to visually correlate urban hotspots with vulnerable social groups and building energy use. This information can transform how the city prepares, proposes, and plans green infrastructure, building retrofits, and cooling corridors. At the same time, this platform strengthens Piraeus' digital and smart city strategy for addressing climate change. We already operate a modern municipal operations center where we monitor air pollution, noise pollution, waste management, public lighting, and other smart city services. The addition of the urban heat analysis platform expands this ecosystem, providing a comprehensive toolset that brings together environmental data and predictive analytics to guide evidence-based decisions for a more resilient city.
In both my roles, I see this platform as a valuable decision support tool. It helps us pinpoint which public spaces are most exposed to extreme heat, guiding actions like shading, renovating squares, or rescheduling outdoor activities. For crime prevention, it adds another layer of insight by showing where heat vulnerability overlaps with high public use, so we can create safer and more comfortable environments, especially for vulnerable groups. What stands out most is how accessible it is. Complex science becomes simple, interactive maps that clearly show our priorities. Different departments can now work from the same evidence, which saves time, improves collaboration, and makes our planning more precise, coordinated, and transparent for the citizens we serve.
The platform could transform our early warning planning by combining heat risk data with information on vulnerable populations like the elderly or those with chronic conditions. For instance, we can finally direct outreach where it's needed the most. It also gives us a clear picture of where support will be required during heat waves, allowing our teams to act faster and coordinate with other departments before a crisis occurs.